Okay, guys, today we're going to talk about ionic compounds, um, which we kind of already did. We talked about the four kinds of compounds, but really the two main categories that we're really going to worry about in here are the molecular compounds, which are the ones you just did, and ionic compounds, which they're all the same, but it's three different types of ionic compounds that we're going to worry about names. So here's the first one. Okay, so go PowerPoint. Okay, so review real fast. Atoms have no charge. Ions, you either have a positive charge or a negative charge, or just ions have charge. Again, all chemical reactions occur because electrons are what are gained, lost, or shared. How do we know whether an atom will be gained or lost? You look at the periodic table. So, remember, columns on the periodic table are called families because they act very similar because of their electron arrangement, which, funnily enough, this has a horrible noise. So lithium has 3 protons, so this first ring would have 2 electrons, the outer ring would have 1. Sodium has 11, 2, 8, 1. And then the outer shell electrons are the ones that are gained or lost. Remember, we kind of briefly talked about these before. Outer shell electrons are called valence electrons. It says outer shell, but really it's the electrons in the highest energy level. We'll go into a little bit more detail in a couple seconds. The magic number of valence electrons is 8. All happy atoms have 8 electrons in their outside shell. Then what will happen? So if an atom only has 1 valence electron, it's going to either give those electrons away or steal them in order to get 8. Again, these are just 2 other random comments. Valence electrons give it their personality because it says how they react with others. So, visual of how atoms combine. So beryllium right here, 4 protons. So 2 electrons in the middle, 2 electrons in the middle, 2, right? 4 protons, 4 electrons. Oxygen has 8, 2 in the first ring, then 6 in the next ring. Again, these are the simplified ways of drawing ion atoms. So what's going to happen? So look, this one has 2 to give. This one, it's got 2. Is it easier to steal 6 from somebody or give away those 2? Well, what's going to happen is that electron's going to move over and that electron's going to move over. And then what is the result? This guy just lost 2 electrons. So now this guy's charge is a 2 plus, and then this guy now is a 2 minus. So that's just what happens. So if you have 4 less electrons in this valence electrons, this really should say valence electrons. If you have 4 less valence electrons, you generally give them away. So you become a positive ion. If you have 4 less, it's easier to steal them. Again, still valence electrons. So right, this guy had 2, this guy had 6. 2 gave it away, 6 stole 2. Okay, now, these next slides are going to be the periodic table. So the best periodic table is the one I gave you on cardstock. If you still have it, that's awesome. This unit is where this periodic table is going to come in the most because the backside has other information we're going to use in the next few days, but I'll refer to it. So if you look, so up here also in this top corner of the things are the charges. This whole column, hydrogen is +1, because it only has 1. And then this whole column, if you look, they're all 2. These guys, some of them are 1 number, but some of them are random. This whole column, look, at least is a 3 plus, 4 plus. The top one and these ones are going to be the charge. So, here's that. When we did periodic table, we did valence electrons. So this is those 2 combined. So why does this first column have a 1 plus charge? It only has 1 valence electron. And it's going to lose it. So it's going to lose 1 electron, 1 plus. This guy is going to also give away those 2 electrons, so it'll make it 2 plus. And we'll write this on a couple slides from now. Okay, now, these guys right here. So these guys right here have all these funky charges. Like that guy has 4 and chromium, all the, like there's multiple charges on here. And the reason for that is what I'm doing on the next slide. When we showed this when we talked about how electrons were arranged. This is the order that electrons fill. So like 1s, 2s, 2p, 3s, 3p, 4s, 3d. So the funny thing is that this is the order they fill. 3d fills, or actually 3p, 4s, 4 fills before 3d, only because 3d has a higher energy. That doesn't mean that 3d is bigger. It just means it has more energy. So like what happens is, here's 1s, here's 2s, here's 2p, remember there were 3, and then 3s then is going to be bigger, and then 3p is going to be even bigger than that. And look, this is all the same color, so there's 3p, and then 4s is going to be out here, but and then 3d, the d's are going to fit right in here. I should do this one in a different color because the d's have those funky shapes. So let's do yellow because it's really not that important. So the d's are the clovers. So one's looking like that, one's looking like, oh, and they should be bigger. So the d's are bigger than this p, but not bigger than 4s. Hopefully that's not too confusing, but it might be. But the whole idea is that s's and p's, like 4s, 3d, 4p, 5s, 4d, 5p, like the s's and p's are always going to fill before they're the higher energy levels. It goes there, like that's the order. After 6s comes 4f. So like 4, 3, 4, 5, like s's and p's are always going to be your highest energy levels, and s's and p's, like, or well, I should circle those. Look, 2, 4, 6, 8 total. That's why 8's the magic number. D's and F's, they do weird things. Those are these sections in here. Technically, this is the D block. These are the F blocks because they're so huge. Like they do funky things. That might be a side note. It's not really important for how ionic compounds. But so, okay, what you really need to know. So on this periodic table, these columns are labeled 1A, 2A, 3A, 4A, 5A. Oh, right here in Roman numerals. So what that means is the Roman numeral is the number of valence electrons it has. So what I want you to do on this, well, this is the next slide. Okay, so now here's the thing. 1A has 1 valence electron. It's going to be a 1 plus charge. 2A has 2 valence electrons. I'm pointing with my finger. You can't. 1A, 1 valence electron. 2 valence electrons, 2 plus, etc. 3A is 3 plus. 4A, oh, these guys, I said mostly 4 pluses. Well, the top, it depends whether you're a metal or non-metal. That's coming up like real soon. 5A has 5. Yes, baby. Okay, so why is 5A? Why does it gain 3 electrons? Well, it's easier. It's going to be easier to steal 3 electrons from somebody than give away their 5. Same thing with 6A, which oxygen was in that example before. It's easier to steal 2 from somebody else and give away. Okay, so 6A will be a 2 minus charge. 2 minus charge. 7A will be a 1 minus charge, and 8A, they have 8 valence electrons. Those are happy. That's why all of these, 0, 0, 0. That's why they don't do anything. Their valence electrons are full. That's why they're noble gases, and they don't do anything. Okay, so what I want you to do on your periodic table, you can write on this one, or, by this one, I mean this, or the other one. But okay, so 1A, the charges we're going to write up, they're going to be 1 pluses. 2A's are 2 pluses. These guys we'll worry about next. 3A, I want you to actually write this on your periodic table. Now 4's technically, like if it's a non-metal, it can be plus or minus 4 because 4 is that middle ground. Most of the time it'll be plus. These guys will be 3 minus, 2 minus, 1 minus, and then 0. So why are we doing this? Because ionic compounds are made of ions. So these numbers that we're writing up here are the charges that I want you to use for the elements in those columns. Okay? So how do you write? Okay, so binary ionic compound, this is the first kind of ionic compound. All it means is 2 ions. Binary means 2. So it's going to be 1 positive and 1 negative. So here you go. These guys, for the most part, if you look, actually if you just look at the charges, they are all pluses. So metals, these are all metals. Remember, this side of the periodic table is metals. They are all pluses. Plus, 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 right? So metals will always be a positive ion. So the shortcut then, a binary ionic compound is going to be a metal and a non-metal. Because ions, you have to have a pluses and minuses so they cancel out. Okay, so how do you name them? So cations and anions are the fancy names. Cation is the fancy name for the positive ion, which is the metals. They're also, the whole left side of the periodic table is, that side, is metals. And funnily enough, so the periodic table reads like a book. So when you write, why are metals written first? Because they're on the left side of the periodic table, so they come first. I'm pretty sure that's the only reason. But they keep their names, kind of like molecular compounds. The first element kept his name. So like calcium, doesn't matter if it's a 2+, it's just calcium. Negative anions or negative ions, they're going to be the nonmetals in today's thing. They're always the right side, so it's just that top little corner, right? So this one, just like before, the ending changes to "ide." So like chlorine changes to chloride. Phosphorus changes to phosphide. Oxygen changes to oxide, right? Like, and then all it's saying, all the ides are, that's just your giveaway that it's an ion now and not just the element. Or an atom. Okay, so how do you name things? It's beautiful. Ionic compounds are easy. You just name the 2 ions. So this guy, look, calcium, the first element keeps its name, the second element changes to ide. So calcium, and then sulfide. 2 ions, strontium bromide. Like, that's it. It's the easiest. Naming is easiest. Sodium oxide. Zn is zinc chloride. Why did we have you memorize the periodic table? Though, because those are all elements we had to memorize. These are the things we use all the time. Zinc chloride. So naming is easy. The trick comes when you write the formula. So notice, though, there is nothing in these names that had anything to do with those numbers. Nothing. Do you see dibromide or disodium or even dichlorine, for crying out loud? No. No more prefixes. Forget that you learned that, okay? Okay, that's a lie. You gotta remember it for Friday. But tomorrow I'm going to tell you how to tell the difference, and it's really easy. G, if your first element's a metal, it's an ionic compound. If the first element's a nonmetal, it's a molecular compound. Yay! There you go. Okay, so an ionic compound is made of ions. It is made of positive and negative ions. But here's the thing. You have to, adding the charges together must add up to 0, because compounds have no charge. Compounds have 0 charge. Neutral. 0. If they had a charge, they would react with everything. Table salt. If it had a charge, it would react with your mouth. It doesn't react with your mouth. It's just your taste buds feeling it. Always the cation is written first. And why do I keep saying cation? Like 99.9% of the time, if it's an ionic compound, it's going to be a metal. There is one negative ionic compound, one positive ion that is called polyatomic, which we'll actually do, Monday. Okay, so if your compound is made of ions, you have to look at charges. I have to go fast because I'm down to 50 seconds. So, step number 1, look, it says write the ions with charges. Well, all you really have to do, and then the charges are based on where they're on the periodic table, those numbers we wrote down. So, potassium and selenium. Now, okay, ready? If this is a 1+ and this is a 2-, in order for that to cancel out, I have to have 2 1+ and 1 Se. So, that's the formula. Calcium phosphide. Calcium is a 2+, phosphorus is a 3-. So, okay, to cancel that out, like, There we go. So really the shortcut is to switch the charges. Cadmium, if you look at the periodic table, is a 2 plus, iodine is a 1 minus. When you flip them, like you just flip them and make them subscripts. So CdI2, magnesium nitride, 2 and 3 again, so they just flip.